Hello everyone, welcome back to Arduino and My Robot. This is chapter 14 and today we'll be doing potentiometer. And if you remember, like we did in the components, basic components, we did this part. This is called as register. And I also told you that these lines, which you can clearly see here, the golden line, the pink line, yellow line, and the brown line, these all lines are used to calculate the resistance value of any register. So when I say resistance value, it means the amount of resistance or amount of hindrance that it will create in the passage of current. Suppose consider it as a speed breaker. Suppose you are going at very high speed of 90 km per hour on your bike. And if there is a speed breaker, you have to reduce the speed of the bike. So similarly, in electronic components, when current is flowing and you want to reduce the amount of current that is flowing, you introduce this component, which is called as resistor. Now the problem with this resistor is that the value of resistance is fixed in this case, right? Suppose I want to make the speed of your bike from 30 to 40. I'll put a signage, move in the speed range of 30 to 40. But if I continuously want to monitor and change the speed as per I want, right? That means the person who is driving. So what I'm going to do is I'm going to accelerate the throttle, right? So there should be a control device by which I can control this resistance, this speed of my bike. Similarly, in electrical components, we need something where we can control the amount of current. Okay, definitely it is going to be a resistance, but how? What kind of resistance? And if I say that I have already told you, do not be surprised. That part is called as potentiometer or variable resistor. So when we say variable means it is going to vary or change. And if you remember this formula, I is equals to V by R. So what happens is I is our current. Let me, yeah. So this here, I is our current and V is voltage and R is our resistance. So when I say I is equals to V by R, you see current and resistance are directly proportional. To increase R, we increase, sorry, I just said current, but it is voltage. Yeah. Voltage and resistance are directly proportional, and current and resistance are inversely proportional. Inversely means when you see anything in the diagonal here, so it means it is inversely when compared to equal to sign. So that means when one component increases, that is when current increases, the resistance decreases. Similarly, when we come to voltage, when the voltage increases, resistance also increases. Now, we must understand that whole chapter was to reduce the amount of current or increase the amount of current based on our uh, current value, based on our resistance value. We'll be going to control these two factors. Okay. Vice versa. Like if we want to increase the current, we'll reduce the resistance. And if we want to reduce the current, we will increase the resistance. How is going how that thing is going to happen is you see this knob, right? You see this particular knob here. We are going to rotate it. So what is going to happen when we rotate this? This is going to change the length of our resistance wire. You see at the bottom here, this is our resistance symbol, and this arrow at the top, this arrow here, this is our knob. Okay. So this knob is actually controlling the length of the wire. So as we slide it to the right or left, this length of resistance wire will change. You see here, this block, consider this as a resistance block. And this arrow pointing downward is our, this arrow is our knob. Okay. Some circuit that is connected and it changes. If we revolve to the clockwise direction and the arrow comes here. So now the resistance has increased, this complete block. Now, if we move it to the left corner, the resistance will become zero and current will be maximum. But if we increase the length to highest here, that is our block to the end of the right side, That means the resistance is highest and current will be lowest. So how are we going to do that? We are going to do that by rotating the knob. So what is happening when you rotate the knob? So you see there are three pins here, one pin, two pin, and three pin. So what is happening is the one end and this second end, blue and green end are connected with the resistance wire. Okay. And this black wire is called as wiper wire. This is actually increasing the length of your resistance. As of now, from here, the pointer where the wiper is and to the left side towards the blue side, that is the length of your resistance. But if you rotate it like this way and our arm's wiper length comes here, then let me point it. Now suppose if I have rotated and my wiper arm is this here. So what is happening here? Now the complete resistance will be this portion. So this is what how we are going to change the resistance of our component. Okay. Now let's understand where to connect these pins and how to connect these pins. So we have three pins. So definitely one pin is going to be connected with a ground terminal. Uh, Other pin is going to be connected with analog, sorry, input voltage, that is 5 volt. So this is going to be connected with 5 volt. Okay. And when I say voltage, you should remember that the voltage is directly proportional to resistance. Okay. So here, if I zoom it, you can see it here. This is written as power and these are analog pins. Okay. So one pin is connected to 5 volt and other pin is connected to an analog input, the center one. The wiper is connected to analog input. So one end is VCC, that is voltage for the voltage 5 volt. The second one, that is wiper wire. This is our output one. And third wire is connected to ground. You can even see the pictorial representation here. Schematic shows us that one is connected to VCC, second is connected to ground, and third is connected to ground, and second one, that is the wiper connected to our rotating part, is connected with the output one. We can also try this. V output pin, that is PWM pin. We can connect any component here. These are our PWM pin, pulse width modulation. Okay, all the pins which have this tilde symbol is the symbol that is on your keyboard just under your escape ESC symbol, ESC button. So that is our tilde symbol. So we can connect our component there on those pins, and input we will be connecting at 5 volt. Don't worry if the circuit is not clear as of now. We'll cover it in great depth in our next session where we'll be doing the project on this. So when you see on your Tinkercad where we'll be doing it, this is the symbol. This is your potentiometer. This is how you will be seeing it on that website. And this black part is wiper. You can rotate it from here to here. Okay. And in reality, you will be seeing something like this. You see here, you can put your pin here and rotate it like this. So two pins are here and this is wiper pin. And or you can see this one with the knob. So this is all about this complete session. And I hope you remember all the previous lecture things that have been taught to you. You have practiced it well on the Tinkercad. Because in the next session, we are going to do coding part and that will require a little bit of revision. And hence, I request you to go back and revise all the previous lectures so that we can cover it in a better way. Thank you.